Hi everyone, my name is Peter. Welcome to this YouTube tutorial. Today's section we are going to look at the pharmacology and we shall look at Parkinsonism. Under this we shall see the pathophysiology and also the drugs used in the management of Parkinsonism. So in this topic, it's very hard for me to talk about the drugs that manage Parkinsonism when we don't know what Parkinsonism is and what causes Parkinsonism. So therefore, in this chapter, I'm going to look at the first half of the pathophysiology of this condition. So therefore, to jump into the topic, Parkinsonism is a neurodegenerative disease that occurs in the basal ganglia. So the basal ganglia is a group of nuclei, cells. There are 5 of them. So we have what we call the basal ganglia. So we have 5 cells that are 5 cells that are involved. First, we have what we call the putamen. We have what we call the caudate. We have what we call the globus pallidus. We have what we call the substantia nigra. Substantia nigra. Then we have what we call the subthalamic nuclei. So these are the 5 major nuclei that make up the basal ganglia, and they are involved in what we call Parkinsonism. So therefore, I'm going to break down the meaning of these words so that as we move further, you understand what really they mean. And to begin with the word basal ganglia, so the word ganglia means of a collection of cells over neurons or something, but as far as the central nervous system is concerned, we do not have ganglia in the central nervous system. So therefore, this is kind of a misleading word. So they are nuclei that work together in the brain. So we have the putamen, caudate. So the putamen and the caudate are called the striatum. The word striatum means stripped, something that is stripped, like that have stripes. Striatum. So the caudate and the putamen form what we call the striatum. So you will hear me talk about the striato-niagara pathway. So I have also what we call the putamen and the globus pallidus. This form what we call the lentiform nuclei. The word lenti means lens because they resemble a lens. So these are the 2 major components that we shall be looking at. So the striatum and the lentiform nuclei both have the putamen. So to go down, the word globus pallidus means global. This means global, while pallidus means pale. So it's like a pale globe. Substantia nigra, substantia like substance, nigra means black. So it's a black substance. Then we have what we call the subthalamic nuclei. Sub means below, thalamic means the thalamus. So it's below the thalamus. So these nuclei are below the thalamus. So basically these are the 5 nuclei that make up the basal ganglia. So now in Parkinsonism, patients usually do not have, they have sufficient or they have no neurons that connect from the substantia nigra to the striatum or to the lentiform nuclei. So this substantia nigra or striato-nigra pathway is connected with dopaminergic neurons, and these neurons are usually seen because they are black in color. That's why it has this substantia nigra. They are black because they have what we call dopamine in them as the neurotransmitter. So we see few of these neurons crossing over from the substantia nigra to the striatum. So therefore, patients who are having Parkinsonism have low dopamine moving from the substantia nigra to the striatum or to the lentiform nuclei. So to go further in understanding what we call how Parkinson comes about, or how movements come about, because we know in Parkinsonism, patients usually have difficulty in movement. They take very slow steps and they have a certain body posture. So we are going to see how this come about. So now next up, I'm going to be discussing what we call the direct and indirect pathways. So we are going to look at what we call the direct and indirect pathways. So have you ever wondered, like for example, in the direct pathway or indirect pathway, they help us in making movements, executing movements. Like for example, take a good example. I can take an example of Tom Brady. He's a quarterback from the New England Patriots. So when Tom Brady is throwing a ball, he uses some muscles, he relaxes some muscles as he's throwing the ball, or he contracts some muscles as he's throwing the ball, whereas the muscles that are not needed are relaxed. So all those coordination in when the direct and indirect pathway are working. Or take a good example, when a footballer is going to make a penalty, how does he stand? How does he move his legs so that he scores the goal, so that he kicks the ball? All those are examples of how we're going to see the direct and indirect pathway. How do they work? So to begin with the direct pathway, so under the direct pathway, we are going to see which type of nuclei are involved and what do they do. So usually it begins, like for example, take a good example, Tom Brady is going to throw a ball, or let me say David Beckham or Cristiano Ronaldo is going to kick a ball to make a free kick. So therefore, what is going to happen? So we have what we call the motor area. That we have the motor area in your in the cortex, usually in the parietal part of the cortex. So which is important in with sensory neurons that send nerve impulses to the rest of the brain. So we have impulses from the motor area to so this is my lentiform nuclei. Remember I said lentiform nuclei is a composition of the putamen and the globus pallidus. So what you have to know is that the striatum is not involved in the motor movements. So it's only the lentiform nuclei that are involved in the motor movement. So therefore, we have, this is my putamen, this is my globus pallidus external, because the globus pallidus is divided into two. We have the globus pallidus internal and globus pallidus external. So these all play a role in the direct and indirect pathway. So this is my globus pallidus internal. So now, imagine Tom Brady is going through a ball. How does he position himself? So the motor area sends neurons to the lentiform, to this area, and these neurons secrete glutamate. So glutamate, yeah, let me use red for the neurotransmitters. Okay, let me use black for glutamate. Then this, remember you're dealing about the direct pathway. So now these neurons connect to the globus pallidus internal. So therefore, in the direct pathway, we do not have the globus pallidus external. It is the globus pallidus internal that is involved in the direct pathway. So therefore, from here, these neurons send impulses to the thalamus. I forgot to draw the thalamus. So this is my thalamus. Then from the thalamus, back to the motor area. So, and the neurotransmitter here is glutamate. The neurotransmitter in red is GABA. So, under the direct pathway, for example, as I was trying to illustrate when Tom Brady is throwing the ball, imagine he's having an opponent on this side and he's trying to throw the ball. So what does his brain tell him? So from the motor area of the body, it helps you, it helps someone, it helps an individual, it helps a person to know where they are. Where are you standing? So it usually tells you that the left leg is in this posture and the right leg is behind the left, and then your arm is in this position. So therefore, when motor impulses come into the central nervous system or into the basal ganglia, a basal ganglia is like an area where it's a consultation area. Like they consult these nuclei. What should we do? How are we going to posture ourselves so that we execute this move? Then the information is integrated within the basal ganglia, and then the results are sent back via still the glutamate. So what you have to note here is that glutamate is the neurotransmitter that brings impulses into the basal ganglia, and it's still the same glutamate that takes out the neurotransmitter. And glutamate is an excitatory neurotransmitter. So therefore, impulses coming from the motor area are going to excite the lentiform nuclei, that is the putamen. So in the putamen, when more glutamate is excreted here, more GABA is going to be excreted. So therefore, we shall have more GABA in this area. So if this neuron is excited, it's going to secrete more GABA. So when this neuron in the globus internus secretes more GABA, it is going to inhibit this neurotransmitter. So therefore, less GABA will be produced here. So when less GABA is being not produced, remember GABA is an inhibitory neurotransmitter. So therefore, less inhibition is going to be made on the glutamate. So we shall have more glutamate. More glutamate. So another name for direct pathway is, it's a stimulation. It stimulates the move. It executes the move. If you want to throw the ball, the direct pathway will help you throw that ball. Well, as the indirect, we shall see what indirect does. The indirect helps all the unnecessary muscles or unnecessary movements will be cut off. So that's the importance of the indirect. So therefore, to recap, to go through further what happens in the direct pathway, impulses from the motor area, sensory area, send impulses via the glutamate neurotransmitter into the lentiform nuclei in the putamen. So then the putamen, this has GABA receptors. So these GABA receptors are the GABA neurons are excited, so they produce too much GABA. So when too much GABA is produced, remember GABA is an inhibitory neurotransmitter, we are going to have less GABA formed by this neurotransmitter here. Still GABA, so it's going to inhibit this GABA. So when this GABA is inhibited, less GABA will be secreted. So when less GABA is secreted, then more glutamate will be produced. Then this glutamate sends back the information back to the motor area or back straight to the muscles through the connecting neurons. So in brief, this is the direct pathway. Then if we talk of the indirect pathway, so in the indirect pathway, we have more nuclei that take part. So we shall have what we call the substantia nigra, and also we shall have what we call the subthalamic nuclei. So if this is my subthalamic nuclei and this is my substantia nigra. So what really happens here is that in the indirect pathway, we do not use the globus pallidus interna. Well, we use the globus pallidus externa. So this is where the neurons end up. So from here, then they cross over to the subthalamic nuclei. From subthalamic nuclei, they connect back to the globus pallidus interna. Then from that, they join the direct pathway, how it works. So therefore, and the direct pathway is inhibitory. So therefore, it's going to stop movements. So how is that going to happen? So let us try again and see. So impulses from the motor area, glutamate, excitatory. So it's going to excite these GABA receptors. So we are going to form more GABA in the globus pallidus externa. So we shall have more GABA in the globus pallidus externa. So when more GABA is secreted, less GABA is going to be secreted here. Less GABA. Because GABA is an inhibitory neurotransmitter, it is going to inhibit this other neuron, GABA neuron. It will inhibit it from producing more GABA. So less GABA will be formed here. So when less GABA is formed here, more glutamate will be formed from here going to the globus pallidus interna. So when this glutamate is excreted into the globus pallidus, it is going to excite these GABA receptors to produce more GABA. So therefore, we shall see more GABA being produced. So when more GABA is being produced, it's going to inhibit this glutamate neurons from sending impulses. So therefore, we shall have less glutamate formed. So when less glutamate is formed, we are going to stop an execution of a movement. For example, if someone is kicking a ball, when someone is going to kick the ball with the right leg, the left leg is going to be inhibited. So the indirect pathway inhibits all the unnecessary muscles, unnecessary areas that do not take part in executing a movement. So that's what happens in indirect pathway. Now we are going to see where does the substantia nigra comes in. So the substantia nigra comes in a way of tuning. So the substantia nigra helps to tune both direct and indirect so that they move smoothly. So from the substantia nigra to the lentiform nuclei, we have what we call the dopaminergic neurons. So if I may use this type. So these are dopamine neurons, or dopa. Let me do it as dopa. So both direct and indirect have dopa. So the direct pathway has D1 receptors, dopa receptors, and the indirect pathway has D2 receptors. So now, if you want to see the importance of substantia nigra, you can easily see patients that have Parkinsonism. So they have less of the gap of the dopa neurons, and you see how these patients are having difficulty in executing movements. Their movements are so small, so slow, and they have a certain body posture. So that's the importance of the substantia nigra. It helps in fine-tuning these movements. So therefore, when dopa binds or excites the direct pathway, it's going to be excitatory. It's going to stimulate. So when more dopamine is produced from more glutamate, we shall have more of the GABA here being produced. So when more GABA is being produced, it's going to inhibit. So we have less GABA here, and then when less GABA is produced, more glutamate will be formed. So that's how the substantia nigra comes in with its dopamine. So dopamine helps to fine-tune these movements. In D2 receptors, it's inhibitory. So when it inhibits this receptor, we shall have less glutamine being produced. So it helps in fine-tuning these movements. And to make the work more messy, where the dopamine neurotransmitter are, where dopa neurons are, we have what we call the acetylcholine neurons. Acetylcholine. So acetylcholine is a neurotransmitter that inhibits dopa. So